Hello everyone, welcome to the iRobo Automation YouTube channel. In this video, I'm going to demonstrate development of ladder logic for the packaging system. That is as per the syllabus. Okay, so this is what the question: to automate the packaging system, that is for 20 marks. So there are three question is divided into three parts. One is process algorithm, then block diagram, then PLC ladder diagram. Okay, so one by one I'm going to explain. So first of all, whenever question is given like this, you need to write the schematic diagram. Okay, and how many number of inputs and how many number of outputs. So everything should be there on the schematic diagram. Okay, so we need to assume. So for simple application I've considered. Okay, so here there is a conveyor belt system, that is conveyor motor is there, and parts or products are there on the conveyor belt. That means it will move on the conveyor belt. There is a photosensor is there, it can detect the product. Okay, and there is a robot that is going to pick the product and placed onto the box, that is empty box. Okay, so the required the working is the start and stop push button is used to start and stop the whole process. Then photosensor is used to detect the product. Once the counting reach 10, the robot arm takes the responsible for packing. That means when you press start button, conveyor motor is on, and products are flowing, products are moving on the conveyor belt, and photosensor detects the item. Once it is counted 10 items, conveyor motor stops, and then robot, assume that your robot is on, or robot is working to pick and place the product onto the empty box. So when 10 products picked up and placed onto the box, that means packing is completed. Okay, so there is a sensor in the that is whenever packing is completed, there is a sensor that is going to give a signal to stop the robot. Okay, to stop the robot, and it will give a signal to start one more time the conveyor motor on. Okay, so that means restart the process. See here, restart the process. So like this, it will keep on going on, but whenever you press stop button, the process is completely stopped. So this is the required working. Means these are the points should be considered for this project. Okay, so now I have designed HMS screen only for understanding purpose. This is a theory exam question, right? So you have to focus on only three things, that is process algorithm, block diagram, then PLC ladder diagram. No HMS screen. But for you to make you understand, I have developed a HMS screen. Okay, in the HMS screen I have added start button, stop button, then manual reset button is there. Manual reset button I have added. Then there is a photosensor, means there is a packaging done sensor is there, on and off I have added. Then there is a display. This display shows that how many parts I have sensed, okay, by the sensor photosensor. So when it is 10, then conveyor motor stops, then robot is going to on. Okay, so this is the HMS screen I have designed. Now what I'll do, I'm going to demonstrate the process first. Go to the PLC logic. This is a PLC logic developed, and I'm going to online mode, that is I'm working on simulation. Right now it is in online. Minimize, then go to HMI project, offline simulation. Adjust the screen. Okay, Right now conveyor motor is off. See it is showing red. Okay, even robot is also off, so it is showing red, and count value is 0. Now first of all you have to switch on the start button and off. See, conveyor motor is on. That means products are moving on the conveyor belt, right? Now you have to assume that sensor is on. For each time whenever product is sensed, a pulse is generated. So you can observe here, counter value increase by 1. See, on, if sensor is on, then count value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When 10 count is generated, then conveyor motor is off, then robot is on. That means now robot is working for a pick and place. That means it picks up the product from the conveyor motor and conveyor belt system and then place it on the empty box. That you have to assume. Now robot is working like pick and place is working. Okay. Once the box is full, then there is a package done sensor will be on. If that is on, it is going to reset the counter value. Again conveyor motor is on, again parts are moving, and this should be released because now it is empty. One more box you have placed manually. Okay, that you have to assume. So now the packaging done sensor is empty. So now the sensor is sensing. So again 10 counts. So again robot is on, again robot is doing pick and place application, and then box is getting filled. When box is completely filled, again it will be on. Again conveyor motor is on, and again empty box is placed, so this sensor will be off. But at any point of time, if you press the stop button, see here, conveyor motor is also should be off. That's because, okay, it should be on, sorry. So see here, conveyor motor is also off, everything is off. So that is given in the question. So this is the logic, ladder logic developed. How we are developed, that is refer the PPT, that means I have given here. This is the step by step. Please go through this. When X0 is on, conveyor motor is on. Okay. When photosensor is on, that detects the product, and we are using counter to count the value of 10 products. And then when counter value is 10, conveyor motor stops and robot arm will be on. That is Y1 will be on. When package is done, X3 sensor is on. That is going to reset the counter. Okay, and manually if you want to reset, for example, sometimes if sensor is not working, then manually you can reset it. Okay. That one additional switch I have added. Then restart process, after packaging done sensor is on, the process is going to restart. But at any point of time, if you press the stop button, the entire process, that is entire outputs Y0 and Y1 are turned off immediately. So this is the sequence of switches and inputs and outputs on. So please go through this. And this is the block diagram. The block diagram, when you press start button, conveyor motor is on and signal will go to the, means products are moving, and a sensor, photosensor detects the item, each product, so one pulse is generated, and that is given to the increment counter. And if counter value is 10, then it is going to stop the conveyor motor and activate the robot arm. And once packaging is done, there is a sensor that gives a signal to reset the product counter. So process will restart. That means again conveyor motor going to start, again process will repeat. This will be continuously repeated. When you press stop button, the process completely stops. Okay, so this is the block diagram. And to develop the ladder diagram, first of all we should list the inputs, number of inputs and number of output. So this is what the inputs and outputs. And output state matrix is very important. Based upon this we can construct the ladder logic. See, in the examination you cannot remember each and every ladder logic for different applications. There could be around 20 applications. You cannot remember those things. So this output state matrix is developed based upon the schematic diagram. That means this diagram you have to refer. Sorry, this diagram you have to refer. Based on this, you have to you have to develop the output state matrix. Once you refer the output state matrix correctly, then it is easy to develop the PLC ladder logic. Okay, so first I'm going to store in the memory bit M0. The start signal I'm going to store in my memory bit M0, and Y0 is conveyor motor. So as soon as memory bit is high, I'm giving a signal to conveyor motor to switch on. Okay, and when count is equal to 10, I'm going to switch off the conveyor motor. See here, when C1 is high, conveyor motor is reset. Okay, again when counter value is 10, when C1 is high, then robot arm is going to on. When packaging dense sensor is sensed, then robot arm is going to reset, and also counter value also reset. Okay, so this is a ladder logic. So if any questions, you can put it in the comment section, or we'll discuss in the classroom. Thank you for watching this video.